Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is the final exam of Math 002 in term 211. Let us solve the final exam together. The range for cosine inverse x is, well, we studied the inverse trigonometric functions in section 5.7. You can go back to the videos about it. And the range for cosine inverse, now x represents the domain of cosine inverse, y represents the range of cosine inverse. And the range of cosine inverse is the domain of cosine. And in section 5.7, we chose a specific domain of cosine in which cosine is one-to-one function, because we cannot find the inverse. We cannot talk about the inverse if the function is not one-to-one. And if you remember, this is the domain we chose for cosine x. In this domain, from 0 to pi, cosine would be 1-to-1, and we can talk about cosine inverse x. And the range of cosine inverse would be equal to the domain of cosine, which is 0 to pi. This form, sine alpha cosine beta minus cosine alpha sine beta, we studied in section 6.2 sum and difference formulas, that this is equal to sine alpha minus beta. So it is in fact sine pi over 3 minus pi over 4. The cofunction of sine 50. We studied in section 5.2 right triangle trigonometries. We studied the cofunction identities, and we have seen that sine 50 equals to cosine 90 minus 50. And 90 minus 50 is just 40. So in fact, cosine 40 is equal to sine 50. Solve this equation for x. Well, this is a determinant. Okay, the determinant. We studied determinants in section 9.5, and this is a 2 by 2 determinant. We know how to find it. We multiply 2 times x minus negative 1 times 5. And this should be equal to 17. So minus times minus is plus, and when we take it to the other side, it would be minus. So we will have 17 minus 5, that's 12. And now we divide by 2. 12 over 2 is 6. So the answer is 6. The standard form of the equation of the ellipse with foci 0, negative 3. We studied ellipses in section 10.1. And to find the equation of the ellipse, we draw first this information, the foci at 0, 3, 0, negative 3. This immediately tells you that the center of this ellipse is 0, 0 because it is the midpoint between the two foci. And it also tells you the C, because C is the distance from the center to the focus. So the C is 3. And since it's an ellipse, so the equation is immediately x squared over something plus y squared over something equals 1. The other information, the vertices are given at 5. So this is vertex 1 and at negative 5. So the distance from 0 to V1 is A. A is the distance from the center to the vertex, so A is 5. And here A is below the Y because this is the y-axis, so A is below y. So here 25, we have to have y squared over 25. So it could be now C or D. Okay, y squared over 25. Now we need to find B. Well, B squared equals A squared minus C squared. So B squared is 16. You know in the ellipse, A squared is the largest. So A squared equals B squared plus C squared. You can watch the video about the ellipse with center 0, 0 in the in the playlist of Math 002. So b squared is 16. So the correct answer is D. The range of this function. This is an exponential function. We studied exponential functions in section 4.1. And we know that the graph of the exponential function with base 3 is like this. Okay. And this line is the horizontal asymptote. It has the equation y equals to 0. So if I go 2 units up, then this would be the new horizontal asymptote. And this point will go here, 2 units up. And this one, x plus 1, means 1 unit to the left. So this point would be here, and the new equation would be like this. Okay. So when the new graph would be like this. So anyway, this plus 2 will take the graph 2 units up, and the new asymptote would be y equals to 2. So the range would be from 2 to infinity open. Find the solution of this inequality. We studied systems of inequalities in section 8.5. To graph an inequality, we first graph this line, x plus y equals to 2. And to graph this line, we choose 2 points, the x-intercept and the y-intercept. If I put x0, y is 2. If I put y0, x is 2. So this point, if this point is 0, 2, this is negative 2, so this is not good. Here, this point is 2, 0, 0, 2, so it could be this one. Here, 0, 2, but this is negative 2, 0, this is not good. This is 2, 0, 0, 2, so it could be this one. So it is either B or D. But now how to find out which one? We know that the graph of this inequality is half a plane. And to determine which half plane, we choose a point. So for example, 0, 0, we choose the origin. So 0 plus 0, is it greater than 2? And the answer is no. So 0, 0 does not belong to the graph. So here 0, 0 is a part of the graph. So this is not the correct one. So D is the correct one. And this is the graph of this inequality, because 0, 0 is not is not a point in the graph, in the half plane. Question 8, which of the following functions has the given graph? Well, he is talking about, anyway, log to the base 10. And log to the base 10, we know that the graph of log to the base 10 is like this. And this line is a vertical asymptote. And we studied logarithmic functions in section 4.2. You can go back to it. So what happened here, this point 1, 0 is taken away, okay, taken away. I don't know how many points, but this line now, which is the vertical asymptote, is taken away 4 points, because it was here, it was x equals to 0, and now the vertical asymptote x equals to 4. So in fact, this graph should pass by this point. Okay, should pass by this point. But anyway, it's clear that the asymptote has been taken to the left 4 units. So it is part C log x plus 4 to the base 10. Because here, this means 4 units up, this means 4 units down, but here 4 units to the left, 4 units to the right. So this is the graph in which we translate this one 4 units to the left. Find the standard form of the equations of a parabola. We studied parabolas in section 10.3. The focus is -5 and 0. So this is the focus. And the directrix is the x equals 5, 3, 4, 5. So this is the directrix. So we know that the center is in the middle. So not the center, the vertex of the parabola in this case. So the parabola will open like this, okay? So the vertex of this parabola is 0, 0. And we have a video about parabolas with vertex 0, 0. And now this kind of parabola, its equation is y square equals 4px. And it opens to the left, so it is negative 4px. And p is the distance from the vertex to the focus, or from the vertex to the directrix. So p is 5, so the equation is negative 20x, and it is A. So A is the correct answer. P is a point on the terminal side of angle theta. Find secant theta. We studied in section 5.3 trigonometric uh, functions of any angle. Okay, we said that this is the point negative 2 and 3. So this is the angle theta, and he wants to find secant theta. So we know that x is negative 2 and y is 3 and r is square root of x squared plus y squared. So it's 4 plus 9, so it's square root of 13. And we know that cosine theta is x over r, so secant theta is r over x by definition. So secant theta should be square root of 13 over negative 2. Well, this one is square root of 13 over negative 2. Notice that this is equal. You can take the minus up if you like, or you can write the minus here if you like. Okay, so it is this answer. The correct answer is B. Solve each of the following equations. Well, we have seen this equation, such an equation, such examples in section 4.4, which is about equations, exponential and logarithmic equations. This is, in fact, an exponential equation. This is also, you can deal with it as a quadratic inform equation. So you can use the quadratic formula if you like. You can write EX equals and use the quadratic formula, or I can just try to factor. This is e to the power 2x, which is in fact EX to the power 2. So I can write EX here and EX here and search for two numbers. Their product is negative 32 and their sum is 4. So it is plus 8 and negative 4. So EX plus 8 times EX minus 4 equals to 0. So now either EX equals negative 8, EX plus 8 equals to 0, which means EX equals to negative 8. But we know that the exponential function starts from 0 to infinity, the range. It cannot be negative. So this answer is in fact rejected. But the other possibility that EX minus 4 equals to 0 or EX equals to 4, and to find, we change it to logarithmic form, or we apply len to both sides. So X would be len 4. So that's the answer. He said round your answer to one decimal place. If you use the calculator, you will find that the answer is 1.4. So len 4 is just 1.38. So you round it to one decimal, you write it 1.4. Use Cramer's rule to find the value of Z only. We studied Cramer's rule in section 9.5 about determinants and Cramer's rule. And there is a special video about Cramer's rule of 3 by 3 matrices, or systems of 3 equations in 3 variables. And if you remember the method is to find the determinant D, and here you write the coefficients of x. So one coefficient of x in the second equation is 0, then 3. The coefficients of y, 1, 1, 0, there is no y in the third equation. And then 2, 3, and negative 2, this is the determinant D. And to evaluate determinants, please, watch the video about section 9.4. We choose either a row or a column. I'll choose the first column, okay? So 1 is multiplied by the minor of 1, in which we remove the row and the column, and we cancel the row and the column, and we write the remaining determinant. And 0 multiplied by anything is 0, so it's not there. Notice the signs plus, minus, plus. So there is then plus 3 times. Cancel the row and the column. So I have 1, 2, 1, 3, and I will have the determinant is -2 minus 0, so -2 plus 3 times 3, 3 minus 2. 3 minus 2 is 1. So -2 plus 3 is 1. So D is 1. And to find Z, we find D of Z, dz. And the determinant of Z, we write the coefficients of X and the coefficients of Y, but we change the column of Z by the constant numbers, okay? At the right hand side. And to find this determinant, I'll do the same. So it is, but this time when I cancel the row and the column of 1, I'll have 1, -2, 0, and 9. And then 0 times anything is 0, and then plus 3 times 1, 7, 1, -2. And I have 9 minus 0 plus 3 times -2, -2 minus 7, that's -9. So 9 minus 27 is just -18, and this is dz. So z is dz over d, so it's -18 over 1, so z is -18, and that's the answer. Part C, find A inverse. We studied the inverse of matrices in 9.4 matrix inverse. And this is a 2 by 2, so to find A inverse, the formula is 1 over the determinant of A, or -15 minus 2, so it's plus 2 times 5, -3, we change their positions and we change the signs of -1 and 2. This is 1 over -13. Now multiply this, so -3 over -13 is 3 over 13. -2 over -13 is 2 over 13. -1 over 13, and -5 over 13. And this is in fact A inverse. Solve the following equations on the interval 0 to 2 pi. Well, I have tan x, tan x. This is a trigonometric equations, section 6.5. So let me take tan x as a common factor. So I have 2 cosine x minus 1 equals to 0. So either tan x is 0, or cosine x, 2 cosine x minus 1 is 0, 2 cosine x equals 1, or cosine x equals half. And now let us solve these two equations. Tan x is 0. Uh, if you use the calculator, tan inverse 0 is 0. Okay, so this is the angle 0. So x here is 0. But there could be another solution. So if I use this, I know that here if the unit circle 0, 1, -1, 0, 0, -1, tan is y over x. So 0 over 1 is 0, and also tan pi 0 over -1 is 0. So in fact, there are two solutions of this equation, 0 and pi. For cosine x equals half, I can ask the calculator about cosine inverse half, and I will find out that cosine inverse half is just pi over 3. But then This is the angle pi over 3 or 60 in degrees. Now cosine this angle is half. Cosine is positive, so also cosine the angle here in the second quadrant with reference angle equals to pi over 3 is also half. And this angle, if this is pi over 3 and this is pi, so this angle would be pi minus pi over 3 or 2 pi over 3. So in fact, cosine 2 pi over 3 is also half. So there are four solutions of this equation. And there are many exercises about trigonometric identities in section 6.5 and the videos about it. Solve this equation, matrix equation for x. We have similar examples in section 9.3 about matrix operations. Well, here 3x, if I take a to the other side, it would be negative a plus b, and then x would be 1 over 3 times negative a plus b or b minus a. So let me find first, so x would be 1 over 3 times. Let me find negative a plus b. So I multiply each number in a by negative 1 and add it to b. So 0 plus minus 9, that's negative 9. Minus 4 is 4 plus 2, that's 6. Minus 1 plus 1, that's 0. Minus 3 is that's 3 plus 0 is 3. So this is in fact negative a plus b. If I multiply by 1 over 3, then negative 9 over 3 is negative 3, 6 over 3 is 2, 0, 1. So this is the matrix X. Solve the system by any method of your choice. We have seen in section 8.1 system of equations in two variables. Two equations in two variables in 8.1, substitution and elimination. I will use here elimination. I can multiply the first equation by negative 2 and eliminate y, or the second equation by negative 5 and eliminate x. So I'll choose to multiply the first equation by negative 2. Okay, by negative 2. So I'll have negative 10x minus 4y equals 18, and this is x plus 4y equals to 9. This is the elimination method. Adding, I have negative 9x. These two would be cancelled. 18 plus 9 is 27. So x is 27 over negative 9, which is negative 3. Now, if I put x negative 3, for example, in the second equation, and solve the second equation for y. For y would be 9 plus 3, that's 12, and y would be 12 over 4, which is 3. So the solution is the ordered pair negative 3 and 3. Expand the following logarithmic expression as much as possible. This is in section 4.3, properties of logarithms. We can write it as log x plus 2 to the power 2 base 8 minus log 64 times cube root of x plus 3 to the base 8. And then I can take 2 outside and write it log x plus 2 to the base 8. And now I have product here, so I can write it log 64 to the base 8 plus log, this is can be written as x plus 2 to the power 1 over 3, the third root, to the base 8. And then it would be 2 log x plus 2 to the base 8 minus log 64 to the base 8 is just 2. You can use the calculator because 8 to the power 2 is 64. And then I have minus, and I can take the 1 over 3 outside and log x plus 2 to the base 8. So this would be the expansion of this logarithm. given the equation of the hyperbola. We studied hyperbolas in section 10.2. And this is a hyperbola with center 0, 0. And we know that the first step is to divide both sides by 144. And when I divide by 144, 16x over 144 minus 9y square over 144, 16x square equals 1. Then simplify, divide by 16, you will have x square over 9 minus y square over 16 equals to 1. And this is a hyperbola with center 0, 0. And to graph this hyperbola, I start from 0, 0, and I go 3 units over x square. I have 3, so 3 units to the right and 3 units to the left, and 4 units up from the center up to here, and 4 units up to here down. And then I graph the fundamental rectangle. If you remember, this is the fundamental up to here. This is the fundamental rectangle. And we know that the diagonals of the fundamental rectangle are the asymptotes. So these are the asymptotes. You can draw them dashed lines or just straight lines, no problem. Okay, these are the asymptotes. And since x squared is positive, the vertices are here. The vertices are here. And this would be the graph of the hyperbola, okay? And he is asking about the vertices. So the vertices are 3, 0, negative 3, 0. So I can say positive, negative 3, and 0. And this is double I, the graph. And look at the foci. The foci would be somewhere here to the right. So how to find the foci? C square is A square plus B square. So 9 plus 16, that's 25. So C is 5. So here is the first focus, and here is the second focus. This is F1, F2, or F1, F2, it doesn't matter. So the foci have coordinates positive or negative 5 and 0. And the equations of the asymptotes would be y equals plus or minus what is below y, square root of 16, which is 4 over what is below x, square root of it is 3 times x. So the equations of the asymptotes are y equals plus or minus 4 over 3 x, and that's the answer of the question. For the system of linear equations, write the system as a matrix equation in the form AX equals to B. Well, we studied matrix equations in section 9.4. You can go back to more examples. A is the coefficient matrix. 1, coefficients of x 0, 3, and coefficients of y 1, 1, 0, and coefficients of z 2, 3, negative 2. I think this is, yeah, the same question, just we are asked, yeah, this one. Yeah, it is the same question exactly. So we know that z is negative 18. All right. This is A multiplied by x, x, y, z, the matrix of unknowns, equals B, the constant matrix 7, negative 2, and 9. And the question now, solve this system using the inverse that's given for the coefficient matrix. So this is A inverse, okay? This is A inverse. So x would be, if AX equals to B, then x is A inverse times B, okay? This is what we learned in section 9.4. So x, which is x, y, z, would be A inverse, which is negative 2, 9, negative 3, 2, negative 8, 3, 1, negative 3, and 1, multiplied by the constant matrix, which is 7, negative 2, and 9. And use the calculator to multiply. Negative 2 times 7, that's negative 14, minus 2 times 2, minus 4, plus 9. So the answer is negative 9. And also 9 times 7, uh, negative 8 times negative 2, negative 3 times 9. Let me check. 9 times 7 plus 16 minus 27, that's 52. And negative 3 times 7 plus negative 2 times 3 plus 1 times 9, this is negative 18. And this is what we found in the previous example. So the answer or the solution set consists of the ordered triple. X is negative 9, y is 52, and z is negative 18. Solve this system by Gaussian elimination with back substitution. Well, Gaussian elimination, we studied Gaussian elimination in section 9.2, and especially 9.1 and 9.2. And here you have 1 to 1, negative 3, negative 5, negative 2, 2, 5, 3, coefficients of phi, x, and z. And we write this vertical bar, and we write the coefficients, the constants here. And then Gaussian elimination, this number has to be 1. It is 1. So we use it to make these two numbers zeros by row operations. So negative 2 R1 plus R2 and negative R1 plus R3. And the new matrix would be the first row is not going to change. And now negative 2 plus 2 is 0. Negative 2 times negative 3 is 6. 6 minus 5 is 1. Negative 4 plus 5 is 1. Negative 24 plus 14 is negative 10. Negative 1 plus 1 is 0. 3 minus 2 is 1. Negative 2 plus 3 is 1. Negative 14 plus 20 is, negative 12. Negative 12 plus 20 is 8. And now the first column is okay. The second column, I have 1 here. So I have to make this number 1. So negative R2 plus R3. This operation will change row 3. Row 1 as it is, and row 2 we will not change in it now. And now let us change. Let us do the operation and see what happens in row 3. Negative 1 plus 1 is 0. Negative 1 plus 1 is 0. Negative times negative is 10. 10 plus 8 is 18. And now I notice that the last row is 0. So we have seen this in section 9.2, inconsistent systems, inconsistent and dependent systems. Now, the last row, I have 0 equals 18, and this is impossible. So the solution set is phi, or the system has no solution, or the system is inconsistent. All right. Given y equals 4 cosine 3x minus pi, find each of the following amplitude, period, phase shift range. Okay, this is part of how graphs of sine and cosine in section 5.5. Amplitude, we know that amplitude is absolute value of 4, so it's 4. Period is 2 pi over b, and b here is 3, okay, the coefficient of x. So the period is 2 pi over 3. Phase shift, to find the phase shift, we put 3x minus pi, the argument equals to 0, and we solve it for x. So it would be pi goes to the other side over 3. So the phase shift is pi over 3. And you can say, if you like, pi over 3 units to the right. Okay. The range, well, this is 4. There is no vertical translation. This is 4. Usually the range of cosine is from negative 1 to 1. If I multiply by r, if the amplitude is 4, then the range is from -4 to 4. This was the last question. I hope you enjoyed watching the solution of this final exam.